Hello, this is Mrs. Moslick, Geometry, Notes 10-6, Secants, Tangents, and Angle Measures. What we are going to do in this set of notes is to know all 4 of the types of angles of a circle. Go ahead and do the warm-up, pause the video, and then go ahead and play when you are done. Okay, the answer is D. Who got D? Excellent. If you did not, this is what you would do. Circumference is distance around a circle, so circumference equals 2 pi r. We also know that circumference equals pi times diameter, but in this case, we'll use the 2 pi r because we want to find the radius. 50 equals 2 pi r. Divide both sides by 2 pi, and the most common mistake that a student will make is putting this in their calculator wrong. You have to put in 50 divided by the quantity 2 pi, or you put in 50 divided by 2 divided by pi. You have to make sure that your answer is for radius is smaller than the amount of fencing, meaning the circumference. It doesn't make sense to have 50 feet around and have a radius that is bigger than 50. So D is your correct answer. You get the radius turns out to be about 7.96, and the question says round to the nearest tenth. And so that would be 8.0. So we'll just say that's 8. So really it should be 8.0 is your final answer. Okay, so the 4 types of angles are: your vertex is on the center of the circle. That is called the central angle. I call that measure of angle 1. That's angle 1. Then when the vertex is on the circle, it's either an inscribed angle or a secant tangent angle. I call that angle 2. So make sure that on your notes that is called angle 2. The vertex is on the circle. We talked about that in section 10.4. Then we have vertexes in the circle. This is different. Vertexes in the circle or outside of the circle are angles 3 and angle 4. This is new. And so let's just make sure that we call this angle 3. Now remember, vertical angles are the same. So measure of angle 3 equals, we have the average of the 2 arcs that angle cuts. And so it equals the sum of those 2 arcs, meaning divided by 2. So it's the average of those 2 arcs. When the vertex is outside the circle, I call that angle 4. And that is angle 4, and angle 4. And you are going to take half of the difference of the big minus the small. 1/2 of the big minus the small. And 1/2 the big, which I call the big arc X, and the small arc Y. Those are the 4 formulas you have to know. You already know the first 2. We just are learning the second 2. So, is the vertex on the center of the circle? Is it on the circle? Is it inside the circle somewhere? Or is it outside of the circle? So where's the vertex? So let's look at example 1. Find the measure of angle 1. First of all, where's the vertex? The vertex is on the circle, so I call that angle 2. So we can change the variable or the question label. That is fine as long as you are labeling it on your paper. So that is angle 2. So the measure of angle 2 equals 1/2 x. X is the arc it cuts off. We don't know what x is, but we can easily find that. The sum of the measures around a circle is 360. So 214 plus x equals 360. So subtract 214 from both sides and you get 146. You don't even have to show that work. So the measure of angle 2 equals 1/2 of the arc it cuts off. We just found out that arc is 146. So the measure of angle 2 is 73 degrees. Number 2, where is the vertex of this angle? The vertex is inside the circle, so we call that angle 3. But however, they're asking us to find x, so that should have really been x. So this is our angle 3. Angle 3 cuts off this arc, and this arc. So again, my mistype, we want to find angle x, or find x. X should be this right here. So we recognize that this is angle 3. The formula for measure of angle 3, where your vertex is inside the circle, it's not on the center, it's inside the circle, is 1/2 times x plus y, where x and y are the two arcs that your angle cuts off. In this case, we have 65 and 51. It doesn't matter which one you identify as x or which one you identify as y. Just as consistency with measure of angle 4, I'll always use x. For angle 4 is the bigger of the two arcs, so I'll just call 65 as our x. So the measure of angle 3 is 1/2 times 1/16. So the measure of angle 3 is 58. Make sure we're answering the question, and the question is to find measure of angle x. Well, x plus the measure of angle 3, they form a line. They are a linear pair, so by the supplement theorem, they add to 180. So we have x plus 58 equals 180. Subtract 58 from both sides. So x is 122. That is the final answer for this problem. Number 3, where is the vertex? The vertex is outside of the circle, so we call that angle 4. So write down that formula. Measure of angle 4 equals 1/2 of x minus y, meaning big minus small. So this is our big arc, we'll call that x, and this is our small arc, we'll call that y. So measure of angle 4 equals 1/2, 130 minus 30. So we have measure of angle 4 equals 1/2 of 100. So our answer here for measure of angle 4, where the vertex is outside the circle, is 50 degrees. So again, just ask yourself, where is the vertex? If it's on the center of the circle, it's angle 1. If it's on the circle, it's angle 2. If it's inside the circle, it's angle 3. And if it's outside the circle, it's angle 4. Last problem, number 4. Where is the vertex? It's outside the circle, so that's angle 4. So measure of angle 4 equals 1/2 of x minus y. X is the big arc it cuts off. You must label it. And the little arc is y. So again, like in our other problems, note that I have labeled the x and the y. Do you guys notice that? So it is necessary that you label the angle as 1, 2, 3, or 4, and you label the arcs it cuts off as x's and y's. So again, make sure you're marking that up. We want to find the measure of arc SR, so eventually we want to find y. Before we do that, we have a dilemma. We have this issue. We have 74 equals 1/2 times the quantity x minus y. I have one equation with two unknowns. What are we going to do? Well, first of all, I don't like to see that 1/2 because that's a little confusing with a fraction. So let's go ahead and multiply both sides by 2. So 74 times 2 is 148 equals x minus y. Much easier equation to work with. But I'm kind of stuck here. Or am I? What else do you notice about the relationship between x and y? You're right. Some of you guys shouted out that x and y form a whole circle. Do you see that? So therefore, I'm just going to change the color here. I know that x plus y equals 360. Their sum is 360. And we just found out that their difference is 148. So we're now going to use two equations, two unknowns. Using algebra, let's use elimination. Let's add the two equations. You must show me that you are adding the two equations. So a big plus sign, big equal sign. We have 2x equals 508. Divide both sides by 2. So x is 254. Oh, just make sure you're answering the question. And remember over here, I said we have to find y. So x plus y is 360, or you can use the other equation. So 254 plus y is 360. Take 360 minus 254, and I get y is 106, and that is my final answer because I already labeled y over here. Okay,